We've learned how to compose two functions. Now we're going the opposite direction. What if a composite function is given to us and we're trying to find two functions that made up that composite function? So given h of x, its absolute value of 2x squared minus 5, this right here is the composite function because it is the result of f of g of x, or f composed g of x. We want to find the two functions f and g such that when you recompose them, we'll get h of x. So as I look at absolute value of 2x squared minus 5, I see two functions. I see an x squared function and I see an absolute value function. So given that g of x is the inside function, I look for what's inside of the absolute value. So g of x would be 2x squared minus 5. And f of x is the outside function, which is the absolute value function. So we're going to write absolute value of x. So when we compose the two functions f of g of x, we are essentially substituting this whole g of x here into x of the f function, and that will give us the original function h of x. So let's check it. F of g of x, f is defined by absolute value of x, but instead of x, I want the g function to be in here. And the g function is defined by 2x squared minus 5. So we substitute that in for g of x. And as you can see, this equals to the function h of x. There could be multiple different answers for this type of problem. Here's another scenario. G of x could also just be 2x squared. So then f of x is the outside function, which is absolute value, but now it's going to be x minus 5. As you can see, if we substitute this in for x in the f function, then we'll get the h function. So let's check it. F is now defined by absolute value of x minus 5, but instead of x, I want g of x, and then minus 5. Substitute g of x. G of x is now 2x squared. Substitute that in for g of x, and then minus 5. And as you can see, this gives us h of x.